Hello, gals and guys. Mr. Ambrose here with another video on Unit 8 on the internet on the CodeHS site. In particular, today, I'm going to look at Section 2, which deals with internet hardware. So my first video in Section 1 was just a brief overview of the internet, and one of the things I mentioned is that the internet is a network connecting individual networks. So, well, the question may be, well, what is a network? Well, a network is at least two or more computer systems that are somehow linked together. So there's various ways that we can link two computers together, and we'll see how we can do that. But here we have perhaps just two computers that are linked together, and as with our internet, if we want to perhaps get information from this computer to here, such as Mr. Smiley Face, right, we can, however the connection is, we can send that over this link and get that's Mr. Smiley Face to the other computer. And so this is a very simple network. If we perhaps increase the number of computers that will be in our network, here's an example perhaps of just 4 computers. And so the question may be, well, how can we perhaps make the connection between all 4 of these computers? And one way may be to literally just connect each computer to every other computer. And while this would perhaps work to be able to send information from one computer to any other one, it's not going to be a good method when you start to get many more computers, such as what we have on the internet, right? It's not going to be sensible for your computer at your home to be connected literally to and physically to every single other computer on the internet. It's impossible. So what do? Well, what we do is we connect perhaps these 4 computers here all to something called a router. And in doing so, this would allow any one of these 4 computers to perhaps connect and send information to another computer. So if I'm on this computer here and I want to send something to that computer there, well, that can be done by just sending that information to the router and also telling the router, hey, send that information to this computer there, and the information is sent. And so if we have information in this computer up on top, want to send it to that computer down there, again, we send that information to this router, which then sends it subsequently to this computer there. And so this router helps with connecting these 4 computers here. And a router would be good when you have a reasonable number of computers that you want to say have all connected together. So say in like a single room, you could have a single router perhaps connecting all the computers in that room, which would allow them to send information from one computer to the other. But as we perhaps get to more complex networks where we have perhaps various networks out there that we want to ultimately be able to perhaps send information from, say, this computer here all the way to that computer there, we're going to have to figure out a different way to perhaps make that connection amongst all these different networks. And so the way that we can do that is that while all these networks have their own router, we then introduce another router that will connect to all of these routers of these individual networks. And so this would allow any computer within these networks to ultimately send information to a computer in another network. So again, if I want to go from this computer here to that computer there, we can go through, send information to this router, which sends that information to this router, which sends it to this router, and then thus to that computer. And this works if you have, a reasonable small number of networks connected by one single router. But as we increase the number of these small networks, that's going to be too much for one single router to handle. It won't be able to efficiently send information, from one of these computers in these networks to another one. So what do? Well, that's where the internet kind of comes into play and operates. In order to be able to handle all of the traffic and all the information being sent from one computer on one network to another computer on a different network, what we set up and how the internet is set up is that the internet itself is just a network of routers. So we have all these routers, and this isn't just all the routers. There's so many different routers out there that kind of make up and form the internet. And while all these routers perhaps and many, many more make up our internet, they're not all, each router isn't connected to every other router on the internet. Each router typically is perhaps connected to just a few routers over the internet. But having all these many, many, many routers out there, somewhat connected to each other, we can then send successfully and in an efficient way information from any computer that's connected to the internet to any other computer that's connected to the internet. And so if say this network here is perhaps your home, and this network here is perhaps the school. If you want to send information from your computer at home to this computer at school, right, we have to, from your computer and router at home, make a connection to a router that's within the internet, and that's typically done through what's called an ISP, which is an internet service provider. An example of that would be, say, like Verizon or AT&T. And then once your router sends that information to a router over the internet, then ultimately that information finds its way through the different routers to the router that is at school, which then sends that information to the computer at school. And so basically that's this network of routers is basically what our internet is. So with that in mind, with that basic idea of what the internet is, now we'll look at perhaps, exactly, how is that information being sent? So the basic idea of the internet is to be able to send information from one computer to another. So if we have Mr. Smiley Face that we want to send from your home to this computer here, right? Again, your computer connects to your router at home, and then that connects to the router on the internet, and then that ultimately gets sent over different routers to the router that connects to the school, and thus that Mr. Smiley Face gets sent to the computer at school. Okay, and again, that's how information is sent. But as you've done work with computers this year, right, computers don't really deal with visual things like this or even words, right? Remember, the basic breakdown of any computer is that its program and how it's function is zeros and ones. And so as we learned, we can convert Mr. Smiley Face into digital information, into just bits, just zeros and ones, and ultimately it's zeros and ones that are being sent over the internet to the other computer, and then that computer takes those bits and converts it and reads it and understands it as being Mr. Smiley Face. So, okay, essentially it's zeros and ones that are being sent over the internet, but how actually does those zeros and ones get sent over the internet from one router to the next? Well, there are 3 different ways in which that happens, either via electricity, light, or radio, are the 3 ways that information, those zeros and ones, are actually sent from ultimately one computer to the next. And so how we perhaps send bits with electricity, this is what we refer to as an Ethernet cable. You may have seen that. An Ethernet cable basically has copper wires in it that you can connect to your computer, which would allow electricity to be sent to and from a computer. And this is one way to perhaps send those zeros and ones. And the pros of using electricity is that it is cheap, but the problem with it is that it only covers medium distances, which won't be efficient when you're trying to send information all the way across the country or the world. Electricity is no good. So, okay, how does electricity actually work to send zeros and ones? Well, when we want to send the bit of 1, we would send a high voltage across the cable. And then when we want to send a 0 using electricity, we would send a low voltage across that cable to send a 0. And that's how we send zeros and ones using electricity. With light, to send zeros and ones from one computer to the next, we use fiber optic cables. And fiber optic cables are probably what makes up the majority of the overall internet and the connections that are made from one router to the next. Because fiber optic cables can extend very, very long distances. The fiber optic cables are what are being, that go across various countries, that actually go across the oceans, and it's through those fiber optic cables that we can send light to transfer the zeros and ones. And while that's a very good pro, the problem with it is that fiber optic cables are very expensive, and it's only those ISPs, those internet service providers, that really use the fiber optic cables to send information. So how do we send zeros and ones using light? Well, when we want to send a one, we send a bright light across the fiber optic cable, and when we want to send a zero, we send either a dim light or either no light across the fiber optic cable to transmit a zero. The last way we send zeros and ones is via radio waves. And radio waves, the nice thing about radio waves is that they are wireless. That's a very, very nice thing. And so examples of information being, sent wirelessly, your router at home is, sending information, using radio waves. And then also a cell tower is a way that we transmit zeros and ones using radio waves. So when you're sending information to and from your cell phone, your smartphone, right, it's using radio waves to transmit zeros and ones. The only problem is that, if you're not close enough to a cell tower or a router, you're not going to be able to transmit your information because radio waves only work over a short distance. So how does a radio wave send a one to a zero? Well, in a similar manner to electricity, we send a high frequency wave when we want to send a one, using radio waves from one computer to the other. And we use a low frequency wave to send a zero from one computer to the other. So that's how the three different ways that we send information, I should say send bits from one computer to the other. So now let's look at this in just a little bit more detail, because there's something else that has to occur to successfully transfer or send those ones and zeros. So if we want to send the bits 1010 from this computer to here, whatever mode of transfer we use, light, radio waves, electricity, right? We can start off by, transmitting perhaps a, bright light if using lights to transmit the one, then a dim or no light to transmit the zero, and then a bright light to transmit the one, and then a zero to transmit, dim light or no light to send and transmit the zero. And so in doing so, we would have successfully transmitted these bits to this computer here with no issues. But if we take this example here, where there are 3 consecutive zeros, there's going to be an issue if we're just sending the light, the bright or the no light, or dim and no light, from one computer to the other. So if we look at this, if we initially send a bright light, the bit of 1 gets transferred. If we then change to a dim or no light, then the 0 gets transferred. But if we keep with the dim and 0 light, this computer, if there's nothing else happening, this computer here won't recognize any other change. And so ultimately what happens is that when we go to send this last one by changing now to a bright light, this computer would have only read 101 because there was no change in the dim light as these 3 zeros were attempted to be transferred. And so this wouldn't work. So the additional thing that has to happen is when we transmit the zeros and ones using, again, any one of the 3 methods, there has to be some time element that has to be agreed upon between the computers, that as we're transmitting, again, bright lights, dim lights, or high frequency wave or low frequency wave, there has to be a time element that's agreed upon between the computers to know that if there are consecutive numbers, for the other computer to perhaps register those consecutive numbers. So if the time element we use here is perhaps per second, if we again use the light transfer, if we start off with the bright light, after 1 second, the computer over here would register the 1, and then after the next second, if we transmit a dim or no light, this computer here would register that 0, and then after another second, if we still have the dim or no light, this computer would register another 0, And then after another second, if we still have the dim or no light, this computer will register that third 0. And then after the next second, we have the bright light back. Then this computer registers this bit of 1, and these bits here are successfully transferred to this other computer here. So besides for these different methods of sending the bits from one computer to the other, we have to add this other element of time. And so here I was using, seconds to highlight, the time to transfer from one computer to the other. If that was the actual unit that computers agreed upon, we would have a super, super slow internet. So we want to perhaps have a faster time. And in order to have faster times, that's going to have to deal with something that we refer to as the bandwidth. And so bandwidth represents the capacity of data transfer in a system, and this is measured by something that we call a bit rate. And bandwidth you can ultimately think of as just the speed of data transfer in your network. So how much actual data can be transferred through your particular system. And bit rate is measured as the number of bits in a system that it can send per second. So if we're dealing with that 1 bit per second, that would be our bit rate that I used in my example. That would be a very low bandwidth. Again, super, super slow. But if we move up to something that is perhaps like this here, like 5 megabytes per second, well, that would definitely be much faster and would correlate to a high bandwidth because there's a much faster speed of information being sent when this is your bit rate. Another term that's used when we're talking about data transfer is a latency of a system, and that's the time it takes for a bit to get from the sender to a receiver. So when we perhaps have a low latency, that actually corresponds to a fast connection, because if it's a low latency, that would mean it's a lower time to send information from sender to receiver, and that would mean, really, really fast connection. And again, as I mentioned, the fiber optic cable is the best, or has the best latency, because it's using light to transmit the information, and that speed is going to be pretty much at the speed of light. So in particular, 1 bit of information requires only 5 microseconds to travel 1 kilometer when we're using the fiber optic cable. Whereas if we use the Ethernet connection, which is connecting via electricity, that's going to require, for 1 bit to transfer, it's going to require 300 microseconds to be transmitted over 1 kilometer. So Ethernet definitely is slower and not as good as perhaps a fiber optic cable. So to summarize this section, right, a network is basically either 2 or more connected computers, and we typically connect networks using routers. And there are various ways that we perhaps make the connection from ultimately 1 computer to the other. It's either through electricity, light, or radio waves. And no matter what the connection may be, right, we are essentially sending bits. You're essentially sending zeros and ones when you're sending information from any computing device to another one. And so there are these terms here: the bandwidth, the bit rate, and the latency, that describe how well your systems actually transfer information from one computer to the other. And that's just terminology that you would hear used when dealing with that. And so that's pretty much it for section 8.02. For this section, please make sure to complete the quiz that's in there. And that's pretty much the only assignment, but I would highly recommend that you watch the Internet is in the Ocean video. I think it's less than 3 minutes, and I think you would find it interesting to see how the connections that are made through the ocean to actually form your internet, how in depth they actually are. And as always, please take care of yourselves, stay safe, and I will talk to you soon.